Hi, this video is looking at terminal velocity. Terminal velocity occurs when the driving force is the same as the resistant force. This means that the object in question will no longer accelerate. The object will have a resultant force of 0, and this is because the two forces, the driving force and the resistant force, are equal. When an object is first dropped, the force of gravity is much greater than the resistant force slowing it down. The resistant force will be air resistance. Therefore, the object will accelerate rapidly. As the speed of the object increases, air resistance also increases. This causes the acceleration rate to fall. The object's speed is increasing but at a decreasing rate. As the object's speed is still increasing, so does the resistant force. The object will continue accelerating at a decreasing rate until the resistant force is the same as the driving force. Then the object will retain this speed. This speed is known as the terminal velocity. So here we have a diagram that shows this. On the x-axis we have time, and on the y-axis we have velocity. The object is dropped at the start of the time period. You can see from the graph that the object's acceleration rate is high at first but then declines over time. We can see this because the line is very steep at the beginning and then it becomes flatter and flatter. The reason why the acceleration rate falls is because as the object's speed increases, the resistant force increases as well. At time t, the object reaches its terminal velocity of v. So let's have a look at the terminal velocity of objects in more detail. The accelerating force acting on all objects is gravity. We can work out the forces of gravity by using the formula below. The formula is weight equals mass times gravitational field strength. Therefore, all objects of the same weight have the same downwards force caused by gravity. However, objects will have different levels of air resistance because objects are different shapes. If an object has a greater level of air resistance, its terminal velocity will be lower. This is because the resistance force is higher for a given speed, meaning that the resistance force will equal the force of gravity at a lower speed. An excellent example is of a skydiver. A skydiver has the same gravitational force pulling it down when their parachute is open or closed. When the parachute is open, there is a greater level of air resistance because of the surface area of the parachute. This means that the terminal velocity of the skydiver will be lower when the parachute is open. As the skydiver opens the parachute, the resistance force is greater than the gravitational force, which causes the skydiver's velocity to fall. The skydiver will decelerate at a reducing rate until its terminal velocity with the parachute open is reached. A skydiver's terminal velocity when a parachute is shut is more than 100 miles an hour. When the parachute is open, a skydiver's terminal velocity is around 15 miles per hour. So let's have a go at drawing a velocity time graph for our skydiver. If you're feeling confident, you can pause the video now and have a go, and then restart it to check your answer. So here is a velocity time graph for our skydiver. Our skydiver jumps out the plane at the start of the time period. The first part of our graph looks exactly the same as what it looked like before. Our skydiver has a very high acceleration rate in the first few seconds, and then over time the acceleration rate falls. Our skydiver then reaches a terminal velocity at point T. Between points T and U, the driving force and the resistant force of our skydiver is the same. The resultant force of our skydiver is 0, and the skydiver remains at its terminal velocity. Our skydiver opens his parachute at point U. When the skydiver opens his parachute, the resistant force increases, and it increases to an amount that is greater than the gravitational force. This results in the skydiver decelerating. The rate of deceleration is high at first and then decreases over time. At point W, the driving force, which was the same as before, is now equal to the new resistant force. This means that our skydiver is now at a new terminal velocity at a lower speed. Our skydiver will stay at this new speed until he lands, and he lands at point X. And that brings us to the end of this video. There is more content, quizzes and past papers on the website. The website is www.elevise.co.uk.